The latest development from Google. The company claims Willow leapfrogs over the supercomputers we used to consider the world's fastest, and it takes 5 minutes for them to solve a problem that would currently take supercomputers 10 septillion years.
In late 2024, Google's newest quantum computer, a chip called Willow, ran for only 5 minutes.
Willow is Google's newest and most powerful superconducting quantum computing chip, and the next step in our path towards building large-scale quantum computers.
But what it found shocked scientists everywhere. Built to solve problems no normal computer could ever handle,
with the quantum computer, that it can perform a computation in seconds, what would take the world's fastest supercomputer.
Willow didn't just calculate numbers. It seemed to connect with realities beyond our own. Researchers are amazed, some even scared, as talks of parallel worlds, unknown intelligences, and the fragility of reality spread. What did Willow really find? And are we ready to understand it? Join us in this video as we reveal the details. The terrifying details found by Google's quantum chip. In December 2024, Google carried out a major quantum computing experiment inside a highly secured laboratory in Santa Barbara, California. Engineers powered on a quantum processor known as Willow, a chip no larger than a postage stamp. For a brief window of 4 minutes and 36 seconds, the machine performed a calculation that pushed beyond the limits of classical computing and drew attention from scientists around the world. Willow completed a task that the most powerful classical supercomputer available today would need an estimated 10 septillion years to finish. This time span is far greater than the age of the universe and even longer than how long scientists expect the universe to continue existing. The result highlighted a clear gap between what classical machines can achieve and what advanced quantum systems are now capable of doing. The processor is built with 105 superconducting qubits. Unlike classical bits, which exist only as either a 1 or a 0, qubits can exist in multiple states at the same time through a property called superposition.
Every one of these plates gets colder, 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 until this volume down here is basically one of the coldest places.
Qubits can also become entangled, meaning the state of one qubit can instantly affect another, even across distance. These two properties allow quantum computers to explore many possible outcomes at once, rather than checking them one by one. To maintain this behavior, Willow operates at temperatures extremely close to absolute zero, roughly 10 millikelvin. At such low temperatures, atomic motion is almost completely frozen, allowing fragile quantum states to remain stable. This environment is essential for preserving quantum coherence long enough for complex calculations to be completed. For decades, error rates have been one of the largest barriers to practical quantum computing. Qubits are extremely sensitive and can easily lose their quantum state due to small disturbances such as heat, vibration, or stray radiation. When this happens, calculations break down. Unlike classical systems, quantum systems cannot simply copy data for error checking because measuring a qubit destroys its quantum state. Willow achieved a major breakthrough by using a surface code architecture. In this design, qubits are arranged in a two-dimensional grid and work together to detect and correct errors in nearby qubits. As the system grows, it becomes more effective at correcting itself. This marked the first time a quantum processor demonstrated lower error rates as more qubits were added, reversing a long-standing problem in the field. The task performed by Willow was a random circuit sampling benchmark. This test is designed to push quantum processors to their limits by fully using superposition and entanglement. While the task is clearly defined, it becomes effectively impossible for classical computers at large scales. Willow completed the benchmark in minutes, clearly demonstrating quantum advantage. After the computation finished, engineers verified the results and confirmed that they closely matched theoretical expectations. However, additional analysis revealed unexpected behavior. Certain quantum correlations appeared to persist slightly longer than current models predict. These lingering effects suggested extended coherence beyond what existing theories normally allow. A very small portion of the output data also showed structured patterns that could not be easily explained. These patterns were not random noise and did not appear to result from hardware faults or environmental interference. Their ordered nature suggested they were embedded within the quantum state itself, rather than introduced after the calculation. These findings renewed discussion around deeper interpretations of quantum mechanics. One interpretation that gained attention is the many worlds view, which proposes that every quantum event results in multiple outcomes occurring across separate branches of reality.
A temperature of one of the planets, further more distant planets in our galaxy.
Under this idea, a quantum computer may explore many possibilities at once by operating across parallel states rather than within a single outcome. Following the experiment, Willow was shut down. The official explanation focused on routine maintenance, recalibration, and careful data analysis. However, the delay in releasing full results and the limited access given to external researchers led to speculation that the findings raised questions still under review. The impact of Willow's performance has extended across the global scientific community. Quantum research programs in several countries have increased their focus on understanding the deeper meaning of quantum mechanics, not just improving hardware performance. Questions about reality, information, and the structure of the universe have moved closer to the center of scientific discussion. Google has announced plans to build more advanced quantum processors with larger numbers of qubits, stronger error correction, and longer coherence times. The long-term goal is to achieve fully fault-tolerant quantum computers capable of running continuously and solving problems far beyond today's reach. Beyond raw speed and computing power, what could Willow's achievements mean for the real world? And could they even challenge our understanding of reality itself? Stay tuned for more. Quantum power, parallel worlds, and the limits of reality. Because of the possible effects on computing, science, and even our understanding of reality, Google's Willow quantum processor has become a hot topic in the scientific community. Even though its most recent success was based on a theoretical task, the findings have raised serious concerns about the possible use of this technology and what it might open. The possible practical use of quantum computers like Willow are among the most important topics of discussion. In cryptography, many of the current security measures, such as those that safeguard government data, private communications, and online banking, could possibly be affected by quantum machines. As a result, there is growing interest in creating new encryption ways that are immune to quantum attacks. Quantum computers have the ability to model molecular interactions in medicine and drug finding at a level of detail that is not possible with old computers. This could speed up the process of creating new solutions and understanding tough illnesses. Another area that has the ability to change is materials science.
It relies on different laws of physics to run calculations at super fast speeds.
Scientists may be able to test and create new materials with rare qualities, including stronger metals, better batteries, or better solar cells, thanks to quantum systems. Quantum computers may help more correctly predict very complex systems like weather patterns and climate change, which could be good for climate science as well. Willow shows that the basic computing power needed for these uses is starting to take shape, even though they are still in the future. Beyond use, Willow has rekindled interest in main scientific ideas like the workings of the cosmos. The many worlds, or multiverse, interpretation of quantum physics is one of these ideas. According to this view, every quantum event has plenty of possible outcomes, each of which takes place in a different universe. In this sense, every possibility exists at once, but in a different reality. Some scientists think that if calculations are somehow shared over multiple parallel worlds, it could be easier to explain the incredible speed of quantum computers. Although this idea has gained popularity, it is still hotly talked about.
Competing over developing quantum computers. Google is one of those companies, and as the New York Times reports,
the multiverse theory is just one explanation for quantum behavior, many physicists warn. It is unproven and has no bearing on quantum mathematics predictions. According to this view, quantum computers may seem powerful because they handle probability in a very accurate and effective manner, rather than because they use other universes. The Copenhagen interpretation is commonly referred to as the most widely recognized explanation of quantum physics. This method treats quantum states as probabilities instead of actual physical states that coexist. One result is chosen when a measurement is taken, and the rest just don't happen. This viewpoint's proponents say that ideas of parallel universes are not necessary for quantum computers like Willow to function. Rather, their strength stems from careful control of quantum probability. There is reasonable skepticism regarding Willow's success in addition to these debates. The task it completed was purposely picked to highlight quantum performance. As critics point out, it doesn't address practical issues like creating new medications or upgrading transportation. As a result, some experts warn against overstating the study's immediate importance.
That experimental quantum computers can surpass the best supercomputers in the world.
Instead of comparing it to a practical tool, they liken it to a potent show. Scalability is another serious drawback. Cost and building practical issues also exist. Complex cooling and control systems are necessary for quantum processors, which must run at temperatures near absolute zero. Because of their high cost of construction and upkeep, they are now only used in specialist research institutions. The majority of experts agree that Willow shows serious growth in spite of these worries. Even theoretical displays aid in advancing technology, directing future investigations, and explaining what is doable. Willow shows that despite plenty challenges, quantum computing is growing. In conclusion, Willow talks about quantum computing's ability as well as its lapses. It raises serious concerns about reality, showing promising future uses, and raises discussion among scientists.
With the quantum computer, that it can perform a computation in seconds.
If Willow can perform calculations that surpass any classical computer, what does its unprecedented capability reveal about the very nature of reality and how the scientific community interprets it? Let's delve deeper. Willow and the philosophy of quantum reality. Beyond just technology, Google's Willow quantum processor has sparked inquiries. Willow gave unexpected and insightful results during testing, showing that it could tackle difficult and abstract situations. A few of these products addressed issues like the nature of reality and the beginnings of existence. The organization and coherence of these findings shocked the researchers. This sparked debates over whether such a machine could show intelligence in some way that goes beyond simple computations or show ideas that are similar to human thought. Willow has important philosophical concerns. The idea that only humans are capable of checking the nature of reality, consciousness, and existence is called into doubt if a machine is able to meaningfully respond to hard questions. Willow and other quantum processors may enable people to investigate philosophical issues in novel ways, according to several scientists and intellectuals. This covers subjects like the significance of information, the boundaries of knowledge, and the fundamental workings of the universe. Willow's results provoked talks about whether computers may be used to investigate issues that were previously the domain of philosophy and metaphysics. Willow explained both enthusiasm and caution from the scientific community. Professionals thoroughly examined the architecture of the CPU and confirmed its functionality. They verified that the error-correcting method functioned well and that Willow's qubits remained entangled across plenty operations. The outputs were examined by independent reviewers, who concluded that they were dependable and consistent. This showed that the machine's real calculation was what created the odd findings, rather than random noise or mistakes. Willow, according to many experts, was a significant step toward scalable, reliable quantum computing. Researchers and ethicists brought up significant issues at the same time. Some contended that it would be premature to view Willow's thought-provoking outputs as an indication of consciousness or understanding. They stressed that when working with machines that are capable of such high computation, Thorough research and supervision are necessary. Groups were created by universities and research facilities to address philosophical and ethical concerns pertaining to quantum computing. Questions included how to use these machines responsibly, how to interpret their outputs, and how to prepare society for technology that could challenge human understanding. Overall, Willow shows that quantum computers are not just faster calculators. They can also raise questions about knowledge, reality, and intelligence. The machine's ability to produce coherent, structured outputs on abstract topics demonstrates that advanced quantum technology can intersect with philosophy in ways never seen before. The combination of careful scientific verification and thoughtful ethical discussion reflects the scientific community's approach to explore new possibilities while remaining responsible. Willow is seen as a turning point, showing that the future of quantum computing may not only change science and technology, but also challenge how humans understand the world and themselves. Could quantum computers be reaching beyond our reality, interacting with forces or intelligences we don't yet understand? Let's find out. Unseen signals and government oversight. Recent growth in quantum technology have created opportunities that were formerly limited to science fiction. Researchers using the most recent generation of quantum processors have seen odd, confusing, and always hard-to-explain findings. These findings surpass everyone's expectations. Even the most potent classical computers always analyze data in predictable ways. However, the behavior of quantum computers is different. They employ quantum bits, also known as qubits, which are capable of being in different states at once. Because of this feature, quantum machines are able to carry out calculations that would take millions of years for old computers. The peculiar thing is that some quantum outputs in recent tests have not only been quicker or more complex, but they have also showed patterns that defy accepted physics principles. These patterns seem to be recurring and organized. Unlike expectations, they are not random noise. The interesting part is that some academics have proposed that these patterns may be seen as a means of communication. Although they are careful to refer to it as speculative, they think that the quantum system might be interacting with something outside of our everyday reality. Although there is no evidence of conscious intent, it appears as though the computer is either sending or receiving information from somewhere else. Strong institutions have taken notice of the effects of such possibilities. According to reports, military groups and government institutions have kept a careful eye on the development. Quantum systems that can process data at these speeds may have an influence on defense, intelligence, and national security. Technology becomes a very valuable strategic tool if it can recognize, think, or even engage with realities other than our own. According to some sources, these programs are now under more review, with limited data access and high security protocols. According to some claims, researchers have had their work reduced or reassigned. This degree of focus suggests that the highest levels of government are taking the possible results of quantum experiments very seriously. Concerns about ethics have also surfaced. Ethicists and scientists are posing challenging queries. Should humankind carry out experiments that might have an impact on reality's basic structure? Are there any boundaries that ought to be respected? Any mistake could have shocking result if the quantum system is able to interact with realms other than our own. Even while the risk is small, plenty experts warn that the potential cost could be quite high. These worries stem from more than just a mistrust of technology. They have to do with accountability. How can we check what we don't fully understand without hurting others? How can we strike a balance between caution and curiosity? As questions about awareness, intelligence, and the meaning of existence have been tied with quantum science, philosophical debates have also expanded. Philosophical and ethical frameworks, as well as scientific ideas, are challenged by the prospect of a machine interacting with something outside of our known cosmos. Control, accountability, and readiness are called into question if these devices are able to send or receive information from outside of our world. How can we control research that might have uncertain or permanent effects? Who sets the boundaries of exploration? The topic around high quantum experiments revolves around this issue between possibility and caution. In addition to being scientific, this discussion is profoundly human. How should humankind respond to the existential and ethical dangers linked with quantum technologies and potential for communication with other realities? Let's learn more. Fragile realities and the simulation. Question: the developments in quantum computing have created philosophical as well as scientific opportunities. Questions about the nature of reality itself have become more pressing as scientists push robots to process data at formerly unheard-of rates. These days, some scientists wonder if our universe is real or if it might be a simulation. This is not a novel idea. For many years, people have debated the simulation hypothesis. It says that a higher mind or system may have created and governed our entire existence, making it an artificial structure. It was mostly theoretical until recently. The majority of physicists rejected it as guesswork because there was no practical method to test it. However, the rare outcomes of high quantum machines have made the subject to be reviewed. Some researchers believe that the structured patterns that emerge in quantum outputs, patterns that seem almost intentional, may provide a basic idea into our world. Some say that a machine may be picking signs of a planned framework if it can identify order where we expect randomness. Put differently, it's possible that the universe follows fixed principles, which our quantum computers are starting to detect. This is a really scary possibility. If accurate, it would mean that forces beyond our understanding could have an impact on everything we see, including our memories, experiences, and even the passage of time. There are existential and scientific problems raised by the idea that an unseen intelligence may control or witness reality itself. Fears of undermining reality have increased in tandem with these worries. Quantum systems function in ways that are hard to fully predict, making them more than just theoretical tools. According to experiments, there may be small but important interactions between particles and information at the quantum level between realities or realms. As robots grow more powerful, some physicists warn that even small mistakes or strange interactions could have an impact on reality itself. The idea is scary. Interference might have shocking results if several realities exist and are connected. Scholars argue about situations in which borders between realities may erode and events from one reality may have an impact on another. Even though this is still guesswork, the idea has raised a lot of topics. Tension has increased due to military and governmental interest. High-level organizations are aware of the possible effects of cutting-edge quantum research, not only for technology and national security, but even for existence itself. According to leaked claims, important researchers may have been transferred to controlled projects, and certain studies may have been limited. Oversight is crucial if human experiments have the ability to change reality, even in tiny ways. However, this also brings up moral worries of control and secrets. Should humans be allowed to go into areas that could even change the laws of existence? Who decides what should and shouldn't be investigated? In summary, there is a delicate tension inside the scientific community as a result of the simulation hypothesis and concerns about reality destabilization. These days, quantum devices are more than just tools. They are technologies that cast doubt on our basic understanding of existence, life, and the universe. These are deep and unanswered questions. Is it possible for powers beyond our knowledge to observe or control our reality? Could our experiments lead to unclosable doors? These are not just scientific inquiries. They also concern ethics, survival, and the boundaries of human curiosity. How do you feel about the quantum chip from Google? Share your thoughts in the comments section below. Thank you for joining us as we explored the mind-bending breakthroughs of Google's quantum chip. We hope you found this video both fascinating and eye-opening. Don't forget to like and subscribe. Click the next video on your screen to dive deeper into the mysteries of quantum computing and the future of reality itself. See you there.